All right, so I am looking at, I think the second problem you sent me, it's number 16. And these problems are quite involved. And I'm kind of surprised that in such a short class, you're moving into material that has so many steps. But I'm going to try to walk you through this and show you what's going on. And I'll probably just make this as one video and send this video to you, and then work another problem that I think shows you the most important concept. So on this one, they give you a function, and they say that the marginal cost is modeled by this function. Whenever you see a fraction, dc dx, you know that this is the derivative. So that's a derivative function. It's a rate of change function. But we want to, let's see what else it says, where x is the number of units. When x equals 15, the cost is 180. It wants us to find the cost function. Okay, so this function right here, as I said, is the derivative of some other function, because this is a rate of change. So this is a derivative function. And the cost function is actually the function that this is the derivative of. So to get the cost function, you have to take the integral of this. Because if you take the integral of this function, it'll bring you back to just the cost function. Because integrals and derivatives are inverses of each other. So if I take the integral of this, it'll bring me back to the cost function. Okay? So I mean, that's a lot of stuff going on there. But just remember, if you ever see this, you have a fraction, it's equal to a function, and it wants you to find another function, it wants you to take the integral of this. It wants you to take the integral of whatever function you were given. So I'm going to take the integral of 14 divided by the cube root 14x plus 9. Again, if I take the integral of that, I will get the cost function. And to take the integral of that, I'm going to use u substitution. I'm going to say this 14x plus 9 is my u. Typically, when you're doing u substitution, if you have a function, this right here is a function, inside another function, the square root is also a function. So you have a function inside of another function. In general, call the inside function u. So I'm going to say that u equals 14x plus 9. Once you have your u, then take the derivative of u, and we'll call that du. Du equals, and I'm going to take the derivative of the u. The derivative of 14x plus 9, well, that's just 14. And then I'm going to put dx. So you're always going to do that when you're doing u substitution. Take the derivative of this, that's where the 14 comes from, and you're going to say du, I took the derivative of the u, du equals the derivative of this, which is 14, and then you'll have a dx here at the end. So it's du equals 14 dx. And now what I want to do is I want to go back to my function that I'm integrating, and I want to see if I can write it all in terms of u and du. Let's see if we can do that. So now this is the integral of 14 divided by cube root. And I should say, I left something out. When you're taking the integral and you have an x, there's always going to be a dx out here. So you're taking the integral with respect to x. So remember, you're taking an integral and you have your variables x. There's always going to be a dx out here. So I'm going to rewrite this whole thing and see if I can rewrite it in terms of u and du. So I have 14. I have the cube root. This 14x plus 9, well, look right here. It's actually u. So I'm not going to put 14x plus 9. I'm going to put u. And look right here. This dx, I want to see if I can rewrite it in terms of u or du. Well, we're pretty close right here. Du equals 14 dx. But I don't have 14 dx. I only have dx. So what I'm going to do is I'm going to divide this by 14 and divide this by 14. And if I do that, I then have du divided by 14 equals dx. You see that? It was du equals 14 dx. So I just solved it for dx by dividing both sides by 14. And when I do that, I get du divided by 14 equals, and of course the 14s cancel out, equals dx. And the reason I did that is because look right here. I have a dx, but I want to rewrite it in terms of du. So it's going to be du divided by 14. So that's going to be du divided by 14. Now, this is what I have right here. There's a few more things I can do. You see this right here? Dividing by 14. If I'm dividing by 14, it's the same as multiplying by 1 divided by 14. So I'll go ahead and write that out. So this is the integral of 14 divided by the cube root of u times, instead of dividing by 14, right here, dividing by 14, that's the same as multiplying by 1 over 14 times du. Okay, I don't want to confuse you right there. Look what I did. Du divided by 14 is the same as 1/14 times du. And there's a reason I did that, is because when you're taking the integral, you can pull out the numbers. You see this 14 right here? I can pull that out to the front. You see this 1/14 right here? I can pull that out to the front. Any of the numbers that are in your integral, you can pull out to the front. So I'm going to do that. This is the integral. This 14, I'm going to pull out outside of the integral, 14. And this 1/14, I'm also going to pull that out to the front. So it's going to be times 1/14. And now in my integral, I just pulled this 14 out to the front. So there's no longer a 14 on the top. It's just a 1 on the top. Divided by, we still have the cube root of u on the bottom. I just pulled this 1/14 out to the front. That's where that came from. So that 1/14 is no longer there. Now it's just a du. So that is du. And if I look at my front, 14 times 1/14, well, that's just 14 divided by 14. And that's just 1. So this goes down to 1. So you don't even have to write it. You don't have to write 1 integral. You can just leave off that 1. And now I'm taking the integral of 1 divided by the cube root of u du. And this is why we do use substitution. Because if I look at what I started with, I don't know how to take the integral of this. I have no idea how to take the integral of this. So what I do is I use substitution, which is what we did all the way through here. And in so doing, it goes down to this. I know how to take the integral of this. I'm going to show you how in a second. But I recognize how to take the integral of this. That's why we do use substitution. We're rewriting a function we don't know how to take the integral of into a function that we do know how to take the integral of. I know how to take the integral of this. I'm going to show you how. So I'm going to take the integral of this function right here. And to do that, I can use the power property because I can rewrite this thing on the bottom as a power. I can rewrite that as a power. And here's how you do it. I'm running out of room here. Let me see. It's going to be the integral of 1 divided by. This right here is the cube root of u. If you take the cube root of a number, it's the same as taking that number, u, and raising it to the power of 1/3. If you raise something to the power of 1/3, it's equivalent to taking the cube root of it. So that's actually 1 divided by u to the 1/3 du. Now I'm going to go over here. I'm going to start doing the rest of it over here. If I have a exponent on the bottom, you see how I have a 1/3 on the bottom? I can actually bring this whole term to the top of the fraction. But I have to make a change when I do that. So that's what I'm going to do. I'm going to take this whole term and I'm going to bring it to the top of my fraction. So it's going to be the integral of, I'm bringing that 1/3 to the top, u, but when I bring it to the top of my fraction, that exponent becomes negative. Negative 1/3. Okay? So all I did is I took this from the bottom and I brought it to the top, but in so doing, the 1/3 becomes negative. So it's u to the negative 1/3 du. So I brought it to the top. And when I bring it to the top, on the bottom, there's just a 1, and I don't have to write it. And this 1 on the top, well, it's still there too, but 1 times u to the negative 1/3 is u to the negative 1/3. So all I did is I took this, I brought it to the top, but when I bring it to the top, the exponent becomes negative. Now I can use the power property. Because when you're doing integration, power property is the easiest thing to use. And the way the power property works, if you remember, you take your exponent and you add 1 to it. So I'm going to go negative 1/3 plus 1. So I'm going to start taking the integral. I'm going to add a 1 to my exponent. You always do that. When you're doing the power property, you always add 1 to your power. Negative 1/3, let me show you over here. Negative 1/3 plus 1 is the same as negative 1/3 plus 3/3. Because what is 3 divided by 3? 1. But the reason I'm doing that is because I need a common denominator. So negative 1/3 plus 1, which I'm going to write as 3/3. If I add these together, it's going to be 2/3. So it's going to be u to the 2/3, and then you divide by your new exponent. So it's going to be divided by 2/3. And just to recap what I did, when you're doing the power property, add a 1 to your exponent. And that's what I did over here. I added a 1 to my exponent. I got a 2/3. And then I divide by my new exponent. So I divide by 2/3. Now, when you're dividing by 2/3, if you remember from arithmetic, when you divide by a fraction, you're actually multiplying by the reciprocal of this fraction. Okay, when you divide by a fraction, you flip it and then you multiply. So dividing by 2/3 is the same as multiplying by 3/2. So that's 3/2 times u to the 2/3. 3/2 times u to the 2/3. And we're almost done with this part of it. But I know what the u is. So I'm going to substitute back into u. You remember from the very beginning of the problem? U, we said, was 14x plus 9. So I'm going to substitute back in the u. So it's going to be 3 halves. It won't be u anymore. It's going to be 14x plus 9 to the 2/3. And when you're doing integration, it's always going to be plus c at the end. I won't go into exactly why. I'm assuming in your previous lessons, the instructor has told you why there's a plus c when you're doing integration. Okay? Basically, when you're doing integration, this is the indefinite integral. The indefinite integral is always going to have a plus c out here. Always. It's just some constant. It's some constant that we do not yet know what it is. And this is going to equal, because remember what we're finding. We're finding the cost function. And it's crazy that they actually put a c here, because the indefinite integral is always going to have a c, but these are not the same c's. Okay? Don't confuse that. It's a really bad problem how they have named their integrals. This is your cost. This c is always there because you're doing an indefinite integral. Indefinite integral is always going to have a plus c, and that's just a number. It's a number that we do not know. And this whole function is your cost function. So it's going to equal your cost. I won't call it c because I don't want to confuse these two c's. They're not the same. This c is not this c. This, like I said, is always part of the indefinite integral. And this function right here is your cost function. But we're not quite done yet, because it says find the cost function. We need a specific cost function. This is an indefinite integral. It can represent any of an infinite number of functions, because I could put any number into my c. I could put a 4. I could put a 5. I could put a million. It doesn't matter what number I put into the c. This c can be any number. So right now, I don't have a specific function. I've got to figure out what this c is equal to. Because if I find out what the c is equal to, then I will have a specific function. All right? And I have, in fact, ran out of room now. So what I'm going to do, I'm going to erase all this stuff right here that we used to get this. Okay, I'm going to erase all this stuff right here so I have more room to work. Again, it's a crazy long problem. Pretty involved. Let me go ahead and erase all this. Make sure I don't erase what I need. There we go. Okay? So we're almost there. But we got this by doing integration. And like I said, this c here, and by the way, again, that is the cost function. Well, it's almost a cost function. We're almost there. We got to figure out what number is that c equal to. When we find out what number that c is equal to, we will then have our cost function. Well, we can do that because look right here. They give us more information. They tell us that the x, this right here, this x, is 15. And when the x is 15, and this is why I don't like this problem, the c is 180. When they say the c, they mean the cost. This is your cost. When your x is 15, then your cost is 180. Okay, so this c represents the cost. Don't confuse it with this c. It was a terrible problem. I can't imagine why they did that. Cost. The cost is 180. So you got to put 180 right here. That's your cost. 180 equals 3 halves. Now I'm going to go 14, not x, because I know what the x is equal to. It's 15. So I'm going to put a 15 in here, plus 9 to the 2/3 plus c. Now look at this. I can figure out what that c is. That's what I want. I want to figure out what number is this c. This c just represents any number. It's part of the indefinite integral. But now I can figure out what it's equal to, because I can figure out what this is. This is just a number. And what you're going to do is you're going to put that into your calculator, and you're going to figure out what number that is. So go to Desmos or whatever calculator you use and plug that into it. Now I'm going to do that myself because I have no idea what that's equal to. So I'm going to go to Desmos. It's an online calculator. You use whatever calculator you use, and I'm going to type that in. I'm going to go 3/2 times 14 times 15 plus 9. Let me make sure I typed it in right. 3/2. So all I'm doing, I'm typing this part right here into a calculator. So I got 3/2 times 14 times 15 plus 9. And that is being raised to the 2/3 power. 2 divided by 3. And make sure I got that all in there right. Yeah. So when I put that in there, and again, I just put this in, this whole thing here, if I put it into the calculator, just make sure I put it in right. Yes, I did. It's going to be just this part. It's going to be 54.498. That right there. So I'm going to have 180 equals 54.498 plus c. Of course, put that in your calculator too, just to make sure I didn't mess up when I plugged into my calculator, but it appears to be right. Okay, so I'm saying that this whole thing right here equals 54.498, and then I just drop down the other stuff, 180 and c. Now I can subtract this stuff over to here, and I'll have what my c is equal to, because I'm trying to figure out what the c is. So it's going to be 180 minus 54.498 equals c. And I'm going to figure out what that's equal to. 180 minus 54.498. That's going to be 125.502. So I'm going to say that c is equal to 125.502. And now, finally, after all that work, we have our cost function. I'm going to write it out. It's going to be, let me see, right here. Here's what I'm doing. We just figured out what the c is equal to. So I now know what this c is equal to. Remember, this was what we got when we did the integral. But to get the entire cost function, I had to solve for this c. And that's what I did. And to solve for it, I plugged in these two values in. I put a 15 into the x. I put a 180 into the cost. I solved for the c, which is 125.502. Now I can plug the c back into this, that right there, and that will be my cost function. So my final cost function is this. The cost equals 3/2. Oops. 3/2 14x. Again, I'm just doing this. 3/2 14x plus 9 to the 2/3 plus 9 to the 2/3. But now it's not plus c. We know what the c is equal to. Plus 125 plus 125 point, and it says round to 2 decimal places, so 0.50. I thought it said 1 decimal place, but we should still be good because you want to make sure you don't get a rounding error. But I did go out 3 places. I thought it said 1 decimal place. Ideally, you go out to like 2 or 3 decimals past what you have to round to at the end. I only went out to 3, but that should still be good. I don't think we have a rounding error here. So it's going to be 125.50, and that's your cost function. That's your cost function. And now, so that goes here. And your next part says, find the cost of producing 90 units. Well, now we have a cost function. So to do this, you just take this 90 and plug it into this x. And that'll give you this answer here. You just put a 90 into that x, put this whole thing into your calculator, and that'll give you that answer right there. So again, I mean, as you saw, that's it's pretty involved to do that, and students struggle with this. Typically, when I'm teaching integration, we take a few weeks learning how to just do integration because it's something that students really struggle with. And again, it's such a short class. I'm surprised they're diving this deep, but I hope that made sense. I'm going to send this one video to you, and then I'll send some other videos to work in some of the more difficult problems.